Hello and welcome. Namaskar, aspirants. Today we'll discuss one of the most important aspect of our UPSC preparation. And right now this topic is quintessentially in the current. The government is focusing on this topic, especially on this nuclear energy. So today we'll start from very base that what is nuclear energy, what are the types of nuclear energy, why nuclear energy is so much important for, in general manner, for our future and for especially for the India's future. What are the various institutions which are working right now in this nuclear energy infrastructure? So let us dwell deeper into this topic and let us understand. So I hope that all of you knows this, what is nuclear energy. Let us start from very base. Basically, whenever you will heat the nucleus of any molecule, especially from the neutron, you have a, suppose there is a, yes, there is a molecule, and at the center of that molecule there is a nucleus. This is the center, and when you break down this center, when you break down this center with a heating of neutron, this broken center proliferate into multiple products. This products called fission product. In a very basic understanding, अगर आप इसको ब्रेक डाउन करते हैं तो आपको दो और प्रोडक्ट मिलते हैं, and in this process there is some kind of energy also dissipate. This energy called, and यही हमको चाहिए, this is the nuclear energy. In the breaking down of this nucleus, the energy liberates, and this is called our nuclear energy. Basically, this nuclear energy has divided into two parts. One is fission and second is fusion. This product, this process, the breaking down of nucleus, it's called fission process. And on the opposite side, when you connect the two atoms, two nucleus, that's called fusion. We'll discuss more deeply. I'm just giving the overview. Okay, the production of nuclear energy will be happen by two ways. One is fusion process and second one is fission process. So how would you define? So nuclear reactions such as a nuclear fission and nuclear fusion. Fission means when single heavy nucleus split into the two smaller nuclei, as we have seen it. And nuclear fusion, when a single heavy nucleus is formed from the combination of the two lighter atoms, nuclei. and release the heavy amount of energy. This process, it's called nuclear energy process. In a nuclear fission reaction, a radioactive decay happens in a spontaneous breakdown of a radioactive atom nucleus and result into the release of energy. That's what we have seen in this image. Let me give you example of what is nuclear fusion, because this nuclear fusion is the base of our energy production of the solar energy. You know that sun has a continuous nucleothermic process. There is continuous ongoing process of a nucleothermic, and because of this process that we get this energy from this for the whole solar system and especially for the earth. What happened? What kind of energy system, nuclear process is happening on the solar, in the sun? So that is a fusion process. In this fusion process, the continuously a lighter element and two smaller nucleus of these lighter elements, they connect and create a new element, and in this process, in this connecting process, they dissipate a large amount of energy, and that's how sun gets its own energy, solar energy, hydro. And in this process, by this process, we have developed a hydrogen bomb. This nuclear fusion process. I have discussed this. In the sun, this process of hydrogen fusion converts 4 million tons of solar nuclear matter per second into the electromagnetic energy, which radiates into the space. Obviously, this is the process. Nuclear energy, in the earlier period, the very much first idea of nuclear energy or atomic energy was surfaced by the Henry Becquerel. The scientist called Baisa, the French scientist, he had imagined in 1896, the way back in time period, that somehow this nucleus have tremendous amount of energy trapped into it, and if we can break down it, we can use this energy as a sustainable energy source. And this person is right. Right now, the nuclear energy is the one of the most trusted source if we can use it safely for our sustainable development. The another thing which we need to understand is nuclear energy is related to heavy elements. What are these heavy elements? Heavy elements like uranium, thorium. These are the heavy elements which continuously release the energy, and that's called radioactive decay. This radioactive decay is a kind of a, why this radioactive decay happen? It's because of the unstable nature of this element. This uranium, for example, let me tell you, the uranium is very unstable in the nature, and because of this instability, the nucleus of this atom release its neutron in the atmosphere, and because of this release, the energy also start to dissipate. And this unstable nature of this uranium or thorium or radon, they act as a potential fissile material. They act as a potential fissile material in our energy production. There are also very smaller atoms which can be used in a fusion process. If you see, so let us discuss between these two important processes of nuclear fission and nuclear fusion. In examination, especially our civil service examination, these two topics, this topic and this subtopic is most important topic. They can ask you from this topic that what are the various ways that you can develop a nuclear energy. So two process, nuclear fusion and nuclear fission. As we have discussed, what is nuclear fission? The splitting of the larger atom into two or more smaller ones. It's known as a nuclear fission. What is nuclear fusion? Fuse यानी together करना यानी इकट्ठा करना. That is a fusing of two or more lighter atoms to form a larger or heavier one in terms of a nuclear fusion. कि यहाँ पे कैसे याद रखेंगे? यहाँ पे तोड़ते हैं. You break down. Breaking down the atom. Breaking down the atom. And here you will unite the atom. Okay. Natural occurrence of the process. It does not occur naturally. It needs to be induced. Like if you want to generate energy from the thorium or uranium or let's say any kind of radioactive material, then you have to put it into a specific under pressure situation. You have to throw the neutron artificially on this element, and from that process it will start a chain reaction of fission. If we talk about fusion, then is it happening naturally into the process, into the nature? So yes, we have the most interesting example of a solar system or of our sun. On the sun, the nuclear fusion process is continuously occurring. It naturally occurs. Our stars get energy from this fusion process. I have given you the example that hydrogen turns into the helium. When two or more hydrogen start to collide, they fuse together and then turns into the helium. The byproduct of the reaction, obviously the massive power, highly radioactive particles are produced in fusion process. Few radioactive particles are produced. However, through the fission triggers, radioactive particles will result from this process. Let me tell you, a fission process, the chain reaction starts, and in this chain reaction, if it goes uncontrolled, if you cannot control this chain reaction, the whole system will collapse. The whole power plant can become a self-destruct, or a kind of we have the example of Chernobyl in Ukraine. You know that the Chernobyl nuclear power plant. This fissile material, they are also very problematic, or kind of we can say the byproduct of this fissile system would leads to the radioactive waste. One of the main problem of this process, a radioactive waste. In fusion process, a few radioactive particles are produced. What are the conditions? A critical mass of substance and high speed of neutrons are basic requirement. How can you generate energy from this fission process? So you required a high speed neutrons, as we have seen this image. What you required? A high speed neutron would collide with this fissile material's nucleus, and then will it divide the or split the atoms into the parts. In this fusion process, you require a high density and high temperature environment. Again, remember the sun. The high temperature environment that creates a necessary condition or situation in which the hydrogen collides, or not collide, but hydrogen fuse together and then transform into the helium. And in this process, it creates a massive amount of energy. Nuclear weapon. So, can this both the process used for the creation of nuclear weapon? So yes, this both the process, nuclear fission and nuclear fusion. This fusion and this fission process, these are the both way for the creation of nuclear weapon. Our earlier atomic bomb are made from this process, and right now we have a hydrogen bomb. This hydrogen bomb, it's used for fusion process. Energy production. So yes, nuclear power plants are practical application of nuclear fission reaction. And experimental technology for producing power, yes, also there. The fuel, uranium is the primary fuel used in the power plants. The hydrogen isotopes are the primary fuels used in experimental fusion power plants. There is a uranium, plutonium. This both are used as a fuel in our fission process. In fusion process, we required a lighter elements like hydrogen isotopes, deuterium and tritium. Because right now we are in the experimental phase in this fusion process. We have a very well established the fission process, but fusion process is into the developing state. We have discussed this point. There are two types of reaction: nuclear fission reaction, nuclear fusion reaction. What happened? Again, let us revise this thing so you can also get. In this fission process, we are splitting the larger nucleus and two smaller nuclei which release the energy. there is a uranium 235. When I hit this nuclear uranium 235 with a neutron, with a high speed neutron, as we have seen, this will split into the two parts. And this splitting process, it generate a bout of energy, a massive energy. And also it generate a more neutron. Again, this neutron will also hit the some other element, nuclear, and that's how this chain reaction starts. This is the way the chain reaction starts. When any uranium nucleus, uranium 235, is bombarded with the neutron, the nucleus splits up into the almost equal fragment with the release of some free neutron and tremendous amount of energy. This is called nuclear fusion. In nuclear fusion process, the two or more lighter animals will combine, collide, and fuse together and form the single nucleus. And then this process is called nuclear fusion. As we have discussed, is the mass product of nucleus is less than the sum of the mass product of nuclei which are infused. Obviously, when this deuterium fused together, it creates a helium. The end product would be lesser than the starting product. So again, let us summarize this thing. Okay, there are two things. Two process of nuclear energy production. One is nuclear fission and second one is nuclear फ्यूजन. फिशन यानी कि ब्रेकडाउन ऑफ एटम. फ्यूजन यानी कि कंबाइनिंग ऑफ एटम, फ्यूजिंग टुगेदर of atom. Not natural process, not a natural process, but this is, yes, it's a natural process. What is example? The example is our basic energy source, the sun, where hydrogen turns into the helium. Nuclear power plants, they are working on this principle of nuclear fission. The number of energy produced, the end product is nuclear waste. In a larger form, end product is comparatively smaller. Smaller quantity. So the hydrogen bomb is the example of a nuclear fusion process. The hydrogen bomb is the example of our nuclear fusion process. So let us talk about the nuclear powers of India. What are the various nuclear powers? What are the status of nuclear power in India? Which organizations are working for nuclear power generation? How this whole idea conceived as a nuclear power? That what is the beginning of our India's nuclear program is called three-stage nuclear program. But whose brainchild is this program? What are the various institutions which are currently working? What are the various power plants? And who manage this power plant? And how this power plant comes into the state? So there are interesting history behind this. So let us discuss about this. Nuclear power in India. So first nuclear reactor, the most important name, the Apsara, the first nuclear research reactor. Its name is Apsara. Remember this, UPSC sometimes in a prelims exam, or if you are also appearing for a state PCS exam, they also ask this kind of question. The first nuclear research reactor's name was or is so Apsara. Or right now this is they can also ask the sentence. They can change the name from Apsara to some other name, and they can ask their first research reactor name is X or Y. Conceptualized by Dr. Homi Jahangir Bhabha. Again, the second question can be asked from this slide. The father of the Indian nuclear program in 1995. So, as I stated you earlier, the first program is designed by conceptualized by Dr. Homi Jahangir Bhabha. He is the person called the father of Indian nuclear program. So remember this thing. In prelims exam, this kind of question is being asked and can be asked in future. The reactor was built with the assistance from the United Kingdom, who provided the initial fuel. Again, the most important thing. Again, from this also question can be asked that the reactor was built with assistance from the United Kingdom. The Apsara reactor, research reactor, was built from the assistance from which state? Which state means which country? So from the United Kingdom, who provided the initial fuel. This man, the myth, the legend, Dr. Homi Jahangir Bhabha. Which department or which ministry right now using or act as a supervisor or surveiller of nuclear energy? So the Department of Atomic Energy, Department of Atomic Energy, which was set up in August 1954. This department act as a head or supervision of our whole nuclear program. And again, remember one thing, that what kind of question can be asked from this information? Department of Atomic Energy directly works under the Prime Minister Office, PMO. Recently, a SPIPA have conducted the exam. In this examination, they have asked this question, that the Department of Atomic Energy comes under the Prime Minister's office. This kind of statement was written, and his statement is right or wrong, you have to answer them. So yes, now remember, the PMO, under the direction of PMO, this Department of Atomic Energy run. And this is the department who work as a head of our nuclear program. All kind of things, all the working facilities, administrative functions comes under, nuclear functions comes under this Department of Atomic Energy. Okay. See the motto or kind of a basic things why this department work. So the what kind of vision we have of nuclear energy? We are not the country who use nuclear energy for the war. We are using this nuclear energy for the developmental purpose. See this vision. From this vision, you can understand many things. That the vision of empowering India through making its energy dependence, through making its energy independent, contributing to provision of sufficient, safe and nutritious food and better healthcare to our people, through development and deployment of nuclear and radiation technologies and their applications. Our aspirations are developing aspiration. We don't want to use this energy for the destruction purpose. We want to use this energy for a developmental purpose. See, this vision says itself, okay, for our sufficient, safe and nutritious food products, better healthcare facilities we can gain, and this energy would be the base of our holistic development. This is the main goal. What is the motto of DAE? So, atoms in the service of the nation. Just remember this thing. As I have said you, DAE works directly under the Prime Minister's office, PMO. The nuclear technology, including nuclear power and research, it's taken care of by this department. What kind of works it done? So this department works in this manner. It engaged to design, construct and operate nuclear power plant, research reactors and support nuclear fuel cycle technologies. It will cover exploration, mining process of nuclear minerals, production of heavy water, nuclear fuel fabrication, fuel processing and nuclear waste program. Ultimately, all the things, what you need to understand here. Department of Atomic Energy, it works all round work of a nuclear facility, from fuel to its waste management. Okay. Department is also developing a new elite crop varieties including oilseed and pulses along with the technique for biological control of pests and pathogens, which will ultimately protect the crops, radiation-based pest harvest technology and radiation-based techniques. So, as I have told you, okay, our aspirations are what kind of aspiration? A developing aspiration. We want energy for development, atom for nations. So, we are using nuclear energy for our sustainable food production, better healthcare facility, we want our agriculture system would be flourished. So department also is working in this sense. Diagnosis and treatment of disease, as I have told you, particularly cancer, technologies for safe drinking water, better environment, and robust industry-centric approaches. What are the contributions of this Department of Atomic Energy and some kind of national initiatives? What kind of initiative it has taken? So in agriculture, again I am repeating the same things, that India's aspiration of a nuclear energy is not for becoming a nuclear power state and using or flaunting this nuclear power and using this energy to intimidate some other countries. We are using this technology for peaceful purpose, for developmental purpose, for our holistic development, for augmenting our capacity, and each and every person can get benefit from this technology. That's what our goal, that's what our vision of our Department of Atomic Energy. And these are the example that we are using this energy for the multi-purpose way. For example, in agriculture, we are using nuclear energy to enhance the production of oilseed and pulses. In education and welfare, various institutions work for this promotion. For example, Homi Bhabha National Institute, a countrywide service in a cancer. In cancer therapy, there is a proton therapy. We have developed this proton therapy. In this proton therapy, small scale nuclear energy would be used. And this nuclear therapy is for what purpose? For the treatment of cancer. Cancer treatment. Food and nutrition security. Radiation based processing of food and agro products enhance and saves the product. Water resources, it also helps in the desalination of water in water scarce area along the sea coast. Desalination purpose, we are using this energy for a desalination purpose. Energy security, obviously one of the most important aspect of our nuclear program. Right now, recently, government has said by 2047, India has targeted 100 gigawatt capacity from nuclear energy. Our nuclear production capacity would be 100 gigawatt. We'll produce 100 gigawatt of electricity from nuclear energy. That's what our goal. Energy sufficiency. The second organization, first is DEA, Department of Atomic Energy. The second is Atomic Energy Commission. India's Atomic Energy Commission was set up in 1948 in the Department of Scientific Research. The important function of the Atomic Energy Commissions are, what kind of work is it do? Atomic Energy Commission. See, immediate after the independence, what we have done? We have done this thing, because we know that future are the energy. If we want to be developed country, we need our energy security. Without energy security, no nation can be flourished. Energy security is at the base of a flourishment, of a development. To organize research for atomic scientists in the country, the first and foremost goal, Atomic Energy Research Center, Atomic Energy Commission's the foremost function is to organize the research capacity of a country, to train atomic scientists in the country. The second thing, what we need? To train atomic scientists. To promote nuclear research in the Commission's own laboratory as well as in India. To undertake prospecting of atomic minerals in India and to extract such minerals for use of an industrial scale. The third important organization or the research and developmental sector in energy generation. So there are various centers of research institutes which are working for energy generation. For example, Bhabha Atomic Research Center, BARC. You have heard the name of BARC. What was I'm telling you about that proton therapy, not protein, proton therapy. It's developed, that proton therapy developed by Bhabha Atomic Research Center. Variable Energy Cyclotron Center. This is also for the healthcare purposes. Global Center for Nuclear Energy Partnership. So these are the centers and research institutes which are right now working in the nuclear energy field. Again, the most important center is Indira Gandhi Center for Atomic Research, Raja Ramanna Center for Advanced Research, Atomic Minerals Directorate for Exploration and Research. Let us talk about Bhabha Atomic Research Center. It's most important center. Bhabha Atomic Research Center, it's a premier multidisciplinary center which work in the field of atomic energy. It has developed its capacity, a kind of excellent infrastructure with a facility of advanced research in the field of nuclear technology, nuclear energy. They have developed a wide array of services. They are working in the field of agriculture, they are working in the field of healthcare, they are working in the field of food sufficiency, food sector, they are working in energy development, they are right now working in a small modular reactor sector, that how we can use. Right now the main issue is the massive infrastructure level of a large nuclear plants, and India is grappling with a high initial capital cost, and also there are various kind of safety parameters which need to be taken care if you want to build a big scale nuclear power plant. So right now we are mulling over the idea of a smaller level of a nuclear power plant, and that's called small modular reactor power plant, SMR. They are very smaller scale, easy to set up, easy to production of energy, and the level of usefulness are also very high. So initial cost will drastically reduced. So right now government is working on this idea. So premier research center, Bhabha Atomic Research Center, you can use. The iron dome, which is used for nuclear reaction purposes. Variable energy cyclotron center. It is also premier research center. Global Center for Energy, Nuclear Energy Partnership. Right now, it is under construction in Haryana. UPSC can ask this kind of centers. For example, from below, which are the institutes are working in the field of nuclear research and nuclear related fields. That kind of question can be asked for your future examination. So there are 3 centers we have seen. The center will consist of 5 schools for advanced research, study and training of a nuclear system and facilities. It is right now under the construction phase. Indira Gandhi Center for Atomic Research. It was set up in 1971. The Indira Gandhi Center for Atomic Research was established under the Department of Atomic Energy. Since the inception, it has been engaged as a multidisciplinary program of scientific research and advancement and advanced engineering. What its aim? Obviously, development of a nuclear technology and especially the fast breeder reactor. We'll discuss about this fast breeder reactor technology in our subsequent lectures. The India's 3-stage nuclear program. What are these 3 stages? Why these 3 stages have conceived? Why it's particularly important for India to develop our nuclear energy in these 3 states to becoming a self-reliant, energy-sufficient India. This Indira Gandhi Nuclear Research Center, they have 2 important facilities. The first is a plutonium-uranium carbide fuel and Kamini reactor, the only operating reactor in the world using uranium-233 fuel, uranium-233 as a fuel. So these are the 2 important achievement or a kind of a uniqueness of this Indira Gandhi Center for Atomic Research. Again, it was established by Department of Atomic Energy, and the main purpose, they are developing the fast breeder reactor for our multi-stage, especially the 3-stage nuclear power program. And what are the importance of this? So uniquely mixed plutonium uranium carbide fuel and Kamini reactor. These are the 2 important facilities of this research center. Raja Ramanna Center for Advanced Research. Department of Atomic Energy have established Raja Ramanna Center for Advanced Technology. Where it is located? So it's located in Indore, Madhya Pradesh. You can see Raja Ramanna Advanced Research Center. Okay. BARC. Again, let us talk about BARC, Bhabha Atomic Research Center. The first batch of scientists from the Bhabha Atomic Research Center, Mumbai, moved to Raja Ramanna Center in 1986, and this initiated the scientific activities. Atomic Minerals Directorate for Exploration and Research. Again, the institutes for atomic energy research and exploration. R&D, you know that most important part of any institute. If you want to build a new age technology, the frontier technology, the cutting edge technology in a nuclear centers, in a nuclear field especially, then we need this kind of a research facility. What they will do? The identification and evaluation of uranium resource required to successfully implement an atomic energy program in the country. And the Atomic Mineral Directorate, they have the mandatory factor of identification and evaluation of uranium resources. पर यानी कि हमारे देश में एटॉमिक एनर्जी के लिए एटॉमिक फ्यूल यानी कि यूरेनियम कहाँ कहाँ पे है उसको ढूंढना, उसका सर्वे करना, उसका एक्सट्रैक्शन करना, ये सारा का सारा काम ये हमारा एटॉमिक मिनरल्स डायरेक्टरेट फॉर एक्सप्लोरेशन एंड रिसर्च देखता है. इसके द्वारा ये पूरा का पूरा काम होता है. Atomic Minerals Directorate for Exploration and Research. You can see this. Atom in the service of the nation. Right now, where is our nuclear power plants? The operational nuclear power plant in India. Again, most important point. Operational nuclear power plants in India. Most important point. Narora Atomic Power Station. They can ask you in a table format that the location of power plant and name of power plant. Location and name you have to remember. So, pay your full attention here. Let us start from the south. In the south, the main important nuclear power plant right now. In Tamil Nadu, there is a Kundalkulam nuclear power plant. In Tamil Nadu, there is a Kundalkulam nuclear power plant. In Karnataka, there is a Kaiga power plant. In Karnataka, there is a Kaiga power plant. In Maharashtra, there is a Tarapur nuclear facility. In Gujarat, there is a Kakrapar nuclear facility. If we go more on northern side, in Rajasthan, there is a I think in a Gangapur region, there is a nuclear research facility. In Uttar Pradesh, in a Narora, there is a nuclear power plant is located. So 1, 2, 3, 4, 5, 6. These are the important locations where nuclear power plants are located. Again, remember this. It's very important. The question can be asked and had been asked, and there will be question from this point of view. So let us discuss about these power plants. On 4 August 1956, the nuclear reactor reached the criticality and was inaugurated on 20 January 1957. The first nuclear reactor in 1956, it was started. Further, another research nuclear reactor and its first nuclear power plant were built with assistance from the Canada. Remember that Apsara, the first research reactor, nuclear research reactor, was built with the help of UK. The second nuclear facility was built with the help of Canada. Question can be asked from this point of view also. Remember, there had been question in this way. This was the example. The nuclear facilities. In 1956, the 40 megawatt research reactor agreement was signed between Canadian and Indian reactors. And this is how we got our second nuclear reactors. India's first nuclear power plant at Rajasthan. Remember, with the help of Canada, research reactor with the help of UK, the first nuclear reactor with the help of Canada, and operation started in 1972. Canada has helped us in development of. Then what happened? After this collaboration, the first nuclear explosion happened in 1974. The first nuclear explosion would happen, and after this first nuclear explosion, United States and its allies have suspended the operation with India. They have ceased any kind of cooperation and collaboration with India. That will not cooperate or collaborate, will not support India's nuclear program. Why? Because India have developed a nuclear weapon in 1974. But we have thrived in this situation. The fourth largest source of electricity in India after thermal, hydropower and renewable energy is a nuclear power plant. The first is thermal, second is hydroelectricity, third is renewable. Right now we have increased our renewable energy capacity to the multiple extents. We'll discuss in further lectures that what is the current status of nuclear energy, renewable energy. Currently, nuclear power plant, with the help of nuclear power plant, we can save around 41 million ton of CO2 emission annually. 41 million CO2 emission we are saving annually compared to the emission that would be generated by the equivalent of electricity generation from coal-based thermal power plants. If we have used the thermal power plant to create the same amount of electricity, then we would have generated the 41 million ton of CO2, but we have saved. Currently, nuclear power plant provides around 3% of the energy generation, electricity generation. And as I have told you, our next focus would be 2047, and how much we want to generate? 100 gigawatt nuclear facility. We are going to produce 100 gigawatt by 2047. Okay. In Gujarat, we have a Kakrapar atomic power plant. Some of you know it or some of you not. This Kakrapar atomic power plant is an important nuclear power reactor in India, because we have recently inaugurated 700 megawatt indigenously built. Remember again, indigenously built fast breeder reactor, FBR, and this FBR is fully functioning. This reactor is fully functioning and its full capacity. Okay. What are the nuclear vision of India? India has flourishing largely indigenous nuclear power program and expected to have 66,000 megawatt electricity nuclear capability in line by 2032. And we have expand this target. Again, I am telling you, by 2047, we want 100 gigawatt capacity. That means 1 lakh gigawatt, 1 lakh megawatt capacity. Okay. So that's what I want to convey you, that our nuclear energy programs are important programs. That's what the basic of our nuclear energy. There are the two types of nuclear energy, fusion and fission. There are various facilities of a nuclear energy, like a Bhabha Atomic Research Center, like a Indira Gandhi Research Center. There is a Directorate of Research and Exploration, the most important department who is working under the Prime Minister's office, PMO, Department of Atomic Energy, who is responsible for all over development of our nuclear program. There are nuclear reactor in various states, in addition, there are targets of future target of India's energy production. So that's what we have discussed in today's lecture. In the next lecture, we'll dwell deeper into this point, that what is India's a three-stage nuclear program, why it is important, and why this kind of program have been conceptualized by the father of nuclear energy, obviously by Dr. Homi Bhabha sir, and we'll critically analyze this program, where we have reached, and can we reach this 100 gigawatt target. We'll discuss this thing in our next lecture, subsequent lectures. Thank you very much. Let us meet in next lecture.